Danny Lennon from Sigma Nutrition Radio on the show, and we discuss circadian eating, which was Danny's topic at the UEBC. So we talk about the central and peripheral body clocks that the body has and how that might affect our eating and the way that we structure our diet, from the timing of our meals, the calorie distribution throughout the day, our consistency within our nutritional habits, as well as our feeding and fasting cycle. Hey guys, so firstly, Danny, what is circadian biology?
Yeah, so there's essentially a branch of biology called chronobiology, which looks at these various different phenomena and biological processes that have a time-based component or run in some sort of pattern. And so a lot of these rhythms can have a time period that is quite short, some are very long. So for example, one thing people are familiar with is that on a regular rhythm or regular cycle, animals hibernate and then have periods of wakefulness, right? So that's something that has this long time frame. The area of circadian biology is a specific branch of chronobiology which concerns about these rhythms that have kind of two main components. So one is that they run at about a 24-hour kind of rhythm. So it kind of that same rhythm will repeat every 24 hours-ish, and we'll surely get to that. And the second thing that makes something circadian is that while it's repeating on a daily cycle, that is a property that's kind of intrinsic to that process. So in other words, nothing externally is what's leading to it being around 24 hours. If you were to have that cell isolated somewhere with no light or temperature or anything like that externally acting on it, it would still have this pattern of about 24 hours. So these rhythms are kind of where we talk about with circadian biology. And there's a few other elements that I'm sure we'll get to about setting rhythms and stuff like that. But one of the kind of things that make what we do in our behaviors, and that's including our eating, as I'm sure we'll come to, our different behaviors, how they influence our circadian rhythms, is that we use external stimuli within our environment to help fine-tune or tweak, or what we refer to as entrainment of these rhythms to a more precise 24-hour cycle. So as I said, these biological processes, for example, that could be, to give people an example of what a circadian rhythm where it could occur, something like your core body temperature has a same pattern that repeats from day to day. It slightly increases over the day, peaks at maybe around 4 or 5 p.m., drops back down, and you'll have like a minimal core body temperature during the night, which helps with sleep. Similarly, we have hormones, one important one being melatonin, that will be fairly low throughout the day and will start to gradually increase as we get towards nighttime. And a few hours before sleep, it'll rise and pass a certain threshold to help with sleep. At least that's one of its functions in a healthy person. So we have these different circadian rhythms, and whilst if we think that as an average, a lot of people would have a rhythm that isn't running exactly 24 hours, right? So if they were left to their own devices, like I said earlier. So what we do is, because our day is 24 hours, we want that to match up with it, we can use things like our light exposure, temperature, and so on for our body to set those rhythms more precisely. So the main thing that will regulate our main circadian clock and our main circadian rhythms will be exposure to light and dark. So light early in the day, ideally, darkness at night. That is a way for our body to detect when it's light, when it's dark, and when these rhythms should be running. So we can now kind of fine-tune those rhythms that, left to their own devices, may run a bit longer than 24 hours on average, and we can get it more in line with that 24-hour process, if that makes sense.
Yeah, no, it does. So it sounds like our exposure to external stimuli can largely influence these internal systems that are operating at a biological level, and it's probably a wise idea to start designing our lifestyle in a way that it's conducive to a biological function. Is that correct?
So that kind of gets us to this concept of circadian alignment and circadian misalignment. So in circadian alignment, we have our circadian rhythms that are set by our central or main master clock. But we also have circadian clocks in all tissues around the body. And so we want those things to be synchronized or running as they should, in alignment, hence the term circadian alignment. And so our behaviors need to be aligned with these kind of processes, or how we want them to run. If we have a certain behavior that causes a shift in some of these circadian rhythms, we can cause circadian misalignment. So for example, our main regulator of these rhythms is light exposure, as I just said. So if you, a common one people will think of is if you give someone a lot of bright blue light exposure at night, that's in conflict with what we'd want. So that can cause a shift in some of these circadian rhythms, can cause circadian misalignment. It's also sometimes referred to as chrono disruption. And now we have this kind of out of sync circadian pattern, and that's associated with all sorts of different metabolic dysfunction and so on. So yeah, we want to look at what things impact these different rhythms and what way should we set up our environment and our lifestyle to kind of maximize circadian alignment and avoid circadian misalignment.
Fantastic. And it sounds like a very important factor in achieving circadian alignment is our exposure to light. So is there an order of priorities in terms of which factors we need to address before we can align our circadian rhythms a little bit better? For example, if we just focused on something that might not be as pivotal to our circadian rhythms as sleep and sunlight exposure, such as our meal timing, would that be jumping the gun to just start focusing on that before you get the sleep dialed in?
Right. Yeah, that's a really important point. So a good way to kind of conceptualize this is, as I kind of briefly mentioned on, but should probably explain a bit more, we have this main central circadian clock that's located in the brain. So it's something called the suprachiasmatic nucleus, or the SCN. It's located in the hypothalamus of the brain, and that's the main things that sets most of our circadian rhythms for things like body temperature, melatonin, and various other things. That also will set circadian rhythms in these other circadian clocks that are located all around the body. So whilst most people know that we have some sort of body clock, and they'll say, oh, when I travel across time zones, my body clock is a bit off. We don't really have just one, right? We have this main central one, but now there's these circadian clocks in all tissues around our body. These are called peripheral clocks. So they can be also influenced and set by that master clock, but they can also be influenced by some of the things like feeding, exercise, sleep, jet lag, things like that. Now, like you said, Rod, before we start worrying about how does our meal timing influence potentially some of these peripheral clocks, we need to say, well, when are we getting light and dark exposure? When are we sleeping and waking? Because they're going to have a much larger impact on this kind of whole circadian biology piece. And when we have that down, then we can start factoring in how do we match up our feeding and fasting times with that. So yeah, you are jumping the gun if you start worrying about meal timing, but yet you have lots of bright light exposure at night. If you are, for example, if this is common with people who do shift work, or people who don't get daylight during the day, things like that, people who have chronically sleep restriction. So those things are probably where we'd start from a circadian perspective, and then we can start asking more of these interesting questions about, well, how does meal timing, if any, play a role, and how do we kind of match these different cycles up?
Awesome. That was a brilliant explanation. So assuming somebody has dialed in their sunlight exposure and they're getting regular, consistent, and adequate sleep, what is then the role of meal timing on these circadian rhythms?
Yeah, so this has kind of really brought a interesting area of research to the fore in the last few years, an area referred to as chrononutrition, which is, again, based on circadian biology, but thinking about how does meal timing and where we place those nutrients across the day potentially influence our health via circadian impacts. And this idea comes about because we know that when we consume nutrients, that can entrain or set these peripheral circadian clocks. So not that central clock. It seems to be specifically in different peripheral clocks located around the body. So that could be in muscle tissue, it's in the intestine, like all tissues around the body typically have these different peripheral clocks. And so if we know that feeding can entrain some of these rhythms there, and we've already said we want circadian alignment, so we want, say, those rhythms set by the master clock to be synced up with those in the peripheral clock, then it makes sense then, well, maybe there are some better times to consume nutrients. And keeping with that line of thought, the hypothesis would be that during the day, that's when we want light exposure. During the night, we want dark exposure. During the day and that light exposure, we should also probably push most of our calories and avoid eating later at night to, again, sink in with this thing. The same way that we would want to be restful during the night and have our activity during the day when it's bright. And so kind of syncing up these different cycles so that we're kind of maximizing that effect, or that's at least the hypothesis. Still quite new in terms of how many like well-controlled human trials we have that can really answer a lot of the specific questions that we're trying to, but there's plenty that I think starts to suggest there is something to this, and that was kind of the idea of the talk, to present here are some different areas of research that may suggest there's something to it. And so the way I tried to outline it was we can look at observationally different things we notice within the research. We can then look at mechanistically, is there any rationale that would make sense that we see differences in either metabolic health or maybe even body composition by eating at different times. Then look at some of the animal data, and then look at human trials, most notably in the area of time-restricted feeding or time-restricted eating, which has become quite popular recently. And it's actually slightly different from intermittent fasting, which we'll probably get to. And in all these different areas of research, what are we kind of seeing? And is it painting us a picture of what's going on?
Awesome. And in terms of meal frequency, we obviously want to distribute some more calories towards the time of day when we're exposed to sunlight. But what is the overall picture mechanistically and from observations that we're seeing in terms of guidelines for people around how many meals they should have per day and during what times?
Yeah, so this kind of gets a bit tricky, but I think one of the things that we know, and I'm sure you've probably discussed on the show before, is that there's no magical meal frequency per se, and that if you're matching for calories and macronutrients, it probably doesn't matter if that person prefers 3 big meals, 6 small meals, or so on. And I think that's a pretty uncontroversial statement. I don't think there's a magical meal frequency that people need to have. So when it comes to meal frequency, I think the only thing that I talked about from this kind of circadian perspective is it probably doesn't matter the exact number of meals, but it more matters the consistency of that. So we have this idea of erratic eating, which you see is quite common in most of the general population. There was a few studies that I mentioned that look at this. And by this erratic eating, we're seeing that from day to day, people have dramatically different meal frequencies. When they have those meals is dramatically different. And so that constant kind of changing in those is probably not a good thing. So having a more consistent or regular pattern either to the number of meals and when they are consumed is at least theoretically would make a lot of sense and can be beneficial. So there's one good study that looked at this, came out of the UK. The author was Al Hussein, and they looked at what they call a regular feeding pattern. So it was a 2-week study where the regular feeding pattern was 3 main meals and 3 snacks. And they did that every day, same time for those 2 weeks. And then they had an irregular feeding pattern where the other condition was anywhere between 3 and 9 meals per day. And it changed every single day across the 14 days of the study. So day 1 could be 3 meals, next day was 8 meals, next day was 4, then it was 9, then it was 8, then it was 2, or 4, and keep switching between 3 and 9 meals every day for these 2 weeks. And what you see there was differences by the end of the study in their glucose tolerance, insulin sensitivity, some glycemic markers like that, which again would suggest for optimal metabolic health, it might be a good idea to have a regular meal timing and consistent, and not just erratic eating at random times and different amounts from day to day, which is quite common, I think, for most people.
Yeah, definitely. And from a hunger and satiety standpoint, is there any implications on this meal consistency on the regulation of appetite?
Potentially. They didn't look at that directly in that Al Hussein study. So I don't know if we had actually see that directly just from a changing of meal frequency like that. Where we do see changes and benefits potentially for appetite is this other area that I discussed of where across the day to place most of those calories. So one of the things that potentially from a circadian perspective makes sense is to avoid eating late at night for sure, and definitely during the night. So we see people that eat during the night or in the early hours of the morning, how you metabolize that meal is very different from if you had it during the day. So your postprandial glucose, so how high your blood glucose goes and stays in that kind of few hours after eating, is much worse at night. You see same things with insulin sensitivity is a lot worse at night. And in fact, insulin sensitivity starts at its highest in the morning and just declines throughout the day. And so we know eating late at night is problematic. And then again, because of that change in things like insulin sensitivity across the day, there's this idea that maybe partitioning more of our calories, or at least biasing more of them earlier, can be beneficial. There's a few reasons to that, which I'll come back to, but specifically on the satiety piece, there's been a couple of those studies that have showed that for the same number of calories and macros in, say, 3 meals across the day, you can see differences in things like leptin and ghrelin potentially if more of them are biased earlier in the day. So that could suggest that for some people at least, it could help them comply with that diet or feel less hungry whilst dieting if they were partitioning it earlier in the day. How many, or if that's for everyone, is probably unlikely, but that would be the only thing that comes to mind on the satiety piece.
So basically no more rapid backloading in intermittent fasting. We're now front loading.
So the kind of punchline that I kind of finished the talk on was that there's lots of interesting stuff that I think is a lot of merit to with this chrononutrition piece. I think it could be very beneficial for people, but whilst there's lots of questions that still remain. There's lots of things that we're quite early in trying to work out, and I'm certainly not saying this is the way anyone needs to eat. Don't do any of this stuff if it leads to you undermining the kind of core fundamental pieces that we know work, right? So if it makes it more difficult for you to do, if it conflicts too much with a work schedule and you can't eat at these times, if you don't feel better doing it, right? If it's harder for you to eat the number of calories you need to, then these things are undermining those fundamental pieces, so not a good idea. But all other things being equal, I think I can make a decent, or at least we can propose give a hypothesis of why, if you put more of your calories slightly earlier, you could see some benefits. So, for example, one of the things you see quite consistent in time-restricted feeding models, and with early time-restricted feeding as well, is that when you restrict that feeding window, people tend to eat less calories. Maybe not that surprising, but you also see things like when more of the calories are biased earlier in the day, people's energy expenditure across the day increases. So there's been a few studies that have pretty consistently shown this. Different mechanisms by which this may be happening. One is diet-induced thermogenesis tends to be higher in the morning than the evening. So what this means is when you eat a meal, you use a certain amount of calories to digest that. And for the same meal given morning or in the evening, that number can be slightly different. And actually, at least to one study, there can be quite a large difference, over 40% in that, between morning and evening time. The other one is the potential for, indirectly, if it influences how active people are throughout the day, that could influence your energy expenditure. One good example here, there was a breakfast study done in Bath by James Betts, was the lead author on it. They actually did 2 studies like this, but one of them particularly looked at what happens when we either have a group skip breakfast and have their first meal at 12, or the other group has a large breakfast of about 700 calories. And so in that condition, they saw that the group that had a 700 calorie breakfast ate more calories, but they didn't gain any more weight than the other group. So what was happening was their energy expenditure was ramping up across the day, and specifically it was that diet-induced thermogenesis increased, and also their physical activity thermogenesis, so just how many calories they're using from being physically active. So at least potentially here we're seeing a model of where when those meals are consumed would influence people's energy expenditure. So that kind of gives an idea of where some of that is coming from. There's a couple other cool studies that look at kind of the calorie distribution thing. One kind of cool one was done by Danielle Yakubovich. She is a researcher out Tel Aviv, and they looked at a large breakfast versus large dinner study. So it was a dieting condition where they were dieting on 1,400 calories per day. they matched macros between both groups, and they just differed on what the size of their breakfast and dinner was. So the large breakfast group had a 700 calorie breakfast, 500 calorie lunch, 200 calorie dinner. Large dinner group had the opposite. They had 200 calories at breakfast, 500 calories at lunch, and a 700 calorie dinner. And in that study, you see there was a pretty dramatic difference in weight loss between the two groups. I think off the top of my head, it was something like maybe 8.6 kilos in the large breakfast group compared to like 3.6 in the large dinner. You see big differences in waist circumference change. There was differences in their blood glucose, fasting insulin, things like that. Definitely at the end of the study, which would make sense because they lost more weight. But also they measured that stuff at the start of week 2 of the study before there was any weight loss differences. And you just saw there was better glycemic control and postprandial glucose response in the large breakfast group. So that would, again, limitations with that study, given the number of people and some other things, how well controlled the number of calories were. So it wasn't a metabolic ward study, or they weren't giving people the food in this particular one. They did in a couple of follow-up studies, actually. But so those things could influence why we saw such dramatic changes, because I don't think we would see them just from an increased energy expenditure. But it at least shows that something is happening when we change meal timing that maybe should make us pause and think, well, when we say that as long as your macros across the day are the same, it doesn't really matter. It's like, largely that's a good point, because most people worry too much about this stuff, and they can still eat at whatever time they want and still put themselves in this deficit and still lose body fat. That's all 100% still true. But this is kind of getting us to think critically of, well, maybe for some people, and we want to look at some of this metabolic health stuff, maybe it could be a good idea to be mindful of where most of our calories are put, or at least how late in the day we end up eating, especially if it's like a large meal right late at night before bed, might not be the best idea based on some of these things.
So breakfast is the most important meal of the day, Dan?
No, I will not go that far to say that. Yeah, so that's the kind of thing that when another thing with this kind of circadian idea is that as I said, if we go with the premise that it makes sense to try and line up feeding with kind of like that daylight exposure when we're awake, you'd probably think, well, I should probably consume some nutrients in the early part of the day. Now, the questions we don't have an answer to is, well, how early does it need to be? How soon after waking? Does it make that much difference? So what I would say is I don't really know. I don't think people need to have breakfast in like the traditional way that we think of it, as like as soon as you get up, go and have a breakfast. It can probably in those first number of hours perhaps, but it makes some sense that in the early part of the day to get some of those nutrients and maybe try and not be super heavy in the caloric load of the very final meal, and try not to have that like super late at night. So yeah.
No, that was very interesting, and I totally agree that we often miss the forest for the trees with nutrition when we think that energy balance and calories and macros are the only things that matter, especially from a health perspective. So I think this just changes the lens at which we look through nutrition, which is always a good idea. And you mentioned earlier that insulin sensitivity is a little bit higher in the morning, drops off throughout the day, and is lowest in the evening. How does exercise and activity influence these circadian rhythms and the alignment of them from our central, biological perspective, and then the synchronization of both nutritional related circadian rhythms with those affected by exercise?
Yeah, so there's a few components to this that I'll mention about exercise. So one is that we do see a similar kind of observation within some of the research that exercise and activity can influence some of those peripheral clocks and entrainment in some of those. I'm not as familiar with the exercise and circadian research as on the nutrition side, but you could probably make
Shocker.
Right, yeah. I know nothing about training. But you could, again, some of the things we see, I mentioned earlier, body temperature and how it changes across the day, and we see this kind of peak in like 4 or 5 p.m. on average. That's kind of some of the reasoning why you probably would have seen people recommend, there's an optimal training time. It's like this late afternoon timing is where you might get best performance, and some of that at least is kind of rooted in some of these processes that are regulated by circadian rhythms like body temperature. The idea with your body temperature is higher, more ready to train, etc. And then there's some other reasons people give too. So there's something potentially to that. But the main thing I would like to talk about with exercise, and actually goes back to what you said at the very start of the question, which is where I thought you were going, was we see this decrease in insulin sensitivity across the day, which means you're essentially becoming more insulin resistant as the day goes on. So that would suggest, well, maybe having carbohydrates at night is not a good idea. We should avoid them, only have carbs in the morning, and so on. At least people might jump to that conclusion. One thing that I mentioned at the presentation was exercise and training, and particularly resistance training, kind of changes that. Because one thing, and I haven't seen this looked at in a circadian sense, but one thing we see separately is that when you have resistance training and muscle contraction, you see the movement of certain glucose transporters from the center of a cell, a muscle cell, to the surface of the cell. These are called GLUT4 transporters. And the significance of this is that usually for glucose to move from our bloodstream into a muscle cell, for example, we use insulin. That's kind of one of its functions. It comes along, attaches to an insulin receptor, and allows glucose to move into a specific cell by getting these glucose transporters working. Now, the thing with this muscle contraction and the movement of these GLUT4 transporters is that this can allow for glucose disposal, or that movement of glucose into a muscle cell, without insulin. So it's called a non-insulin mediated process, or an insulin independent process. And so now, if you've just lifted some weights, for example, or done some other type of exercise, you can probably deal with that carbohydrate load in the evening time without worrying that you're essentially a bit more insulin resistant at the level of the muscle, because you don't need that insulin sensitivity to allow for that glucose disposal. So I do think training changes things quite a bit. And I think that'd be a cool area of research to investigate, at least from the glucose response and a kind of training insulin kind of perspective. Now, there could be some other things why eating large meals at night may be different, but that's one thing. And then, as I'll probably come to, that there's some other caveats of where worrying about these things is probably not beneficial. If we have an athlete and they have a specific goal, and their number one goal is athletic performance, then we're probably going to set up their nutrition in a way that maximizes recovery and performance, and not so worry too much about what is their acute postprandial glucose response to this meal in the evening, right?
Yeah, that was essentially the question that I was alluding to, and how the interplay between nutrition and exercise could potentially, alter insulin and the feeding, the distribution of calories across the day. No, but that's very interesting. So I guess, let's talk about some of the caveats to this whole circadian rhythm approach, when we should focus on it. We've kind of touched on that, but who it might not be necessary to prioritize for, and then some of the limitations, I guess, and things we need to know a little bit more about.
Yeah, sure. So just before getting to that, I should probably mention that kind of the main, let's say, poster child of this line of research has kind of turned into being time-restricted feeding, which has a ton of animal data behind. And I mentioned animal data briefly in the presentation, not because many people tend to be convinced by animal data, and rightly so. There's lots of things that don't translate to humans, but the at least in this area, the thing I find most interesting is that the consistency of the direction it goes is that pretty much every time-restricted feeding model you see done in rodents, they just benefit from it in every different type of marker people look at. And so it's incredibly consistent of the benefits there. In the human data, there's been some really cool trials done, and we can certainly circle back to them. But just to give people some idea, time-restricted feeding is essentially restricting meals to within a certain window of time. So most commonly it's been looked at in like an 8-hour eating window, but that we still don't know what is the best window to eat. But it essentially restricted down from when people would normally eat, and at least some papers that came out of Sachin Panda's lab would suggest a lot of people in the general population have something like a 15-hour eating window, where they're eating soon after getting up in the morning, they're consuming some sort of calories or nutrients late in the evening before bed, and so they're consistently eating throughout the day. And so simply moving that to a restriction of you can eat between these times seems to be potentially very beneficial for a few reasons. One, it can maybe alter how much people are going to consume, but also it seems to have some impacts on some of those glycemic markers I mentioned too. So I think the way I tried to say, okay, this is interesting, there's some cool stuff here, but there's obviously some contraindications that would stop me from saying, hey, everyone needs to go and have like this time restricted feeding, where they have a restricted feeding window, and we also want to put that early in the day based on these hypothetical things. I don't think we're there yet, but I also think there's some contraindications. For example, with I mentioned a couple already. One is training. So when people are actually going to be doing some exercise, that kind of changes the need for this. Two is when you're working with athletes. So for example, I've worked with a lot of athletes that train like twice a day. Their main goal in life is performance. And so moving to a restricted feeding window or any of these types of things I've mentioned may be suboptimal for that if they're trying to recover and fuel for different training sessions as their main goal. That may not be the best idea. Similarly, a lot of them can have very high calorie demands. I'm sure you've had plenty of guys in the gym who struggle to eat enough calories as it already is, and now something like this could make that more difficult. So people trying to gain weight, trying to eat more, then this may be kind of counterproductive. It's easy to think of other examples of that, whether that's people who are, like, you see some Olympic athletes like swimmers, they might need like 8,000 calories a day. Giving them a 6-hour feeding window doesn't really make much sense. It could be someone who is generally under eating, could be a pregnant woman, it could be a number of different people. The other two are more kind of pragmatic. So that these caveats I mentioned was one about social occasions. And so, for example, if they're like when we go out for a meal the other night after the conference, I'm not going to say, hey, it's like 9 o'clock. I'm not eating now. I finish eating at 5, right? When it's more about, in general, you can eat a certain way, but don't let that stop you from things that are still important in life, that still influence your health in certain ways. So I would just be, again, that would be something where I think it's pretty acceptable to break some of these rules and have a lot of calories late in the evening if you're going out for a meal with family or friends. And then the kind of final one is if any of these types of eating strategies make it a lot of hassle for someone to follow, if they find it difficult to do, if it makes them feel more anxious about nutrition or whatever, it makes life more stressful, then it's undermining the things that we should be helping them with. And so if it makes it more difficult for them just to generally eat healthy in the appropriate amounts, or it makes it just a scheduling nightmare, or it just makes them stressed out, then I would say, yeah, it's probably contraindicated. So there are a few examples of where we should maybe be wary of recommending these types of strategies.
Fantastic. And I think we had a discussion over the weekend about potentially putting up your presentation on YouTube to let everybody have an insight into the entire topic and what it's all about, and we plan on doing that. There's going to be a little bit of a catch, though, I think. We've got to get some shares on this podcast here to raise some awareness around it. And if we tick a few milestones, I think we'll put it up for free. So, yeah, Danny, is there anything else you wanted to add about the circadian rhythm? I think we covered very broadly the nuts and bolts.
One thing, that I do want to, I think is important to reinforce, and I've kind of alluded to it, but just to make it really clear to people, because I think when people first hear this, they may have a initial reaction one way or the other. I am very much, in terms of what I think we can actually confidently conclude right now, there's only a few things. So like I said, it probably is a good idea to think about when you're getting light and dark exposure. I think it's a good idea to probably try not to eat very late at night. I think it's a good idea to have, ideally, eating patterns that are not erratic in nature. And I think if it's for a lot of people, they may find it beneficial to just have a restricted feeding window. Now, the question is, how long does that be? We have no idea if 8 is better than 7, or if 9 or 10 is okay, or 6. We still need to work that out. But it seems a very simple intervention for a lot of people, particularly in the general population, to have a restricted feeding window that may be of benefit. probably in the first number of hours across the day. Again, we don't know how many. It might be a good idea to have some sort of nutrient ingestion and maybe just not have a lot of calories late at night. Beyond that, the rest is just still a lot of questions up in the air. And I kind of put this stuff more out of like, this is interesting. I think there's a lot of stuff to this. To some degree, you could say like the writing is on the wall for a lot of it, but we still need to figure out a lot of these questions. So I'm certainly not getting people trying to promote the idea that everyone needs to follow a model of eating like this. And again, certainly not to the point if it was going to undermine any of the other fundamental things that make a bigger impact of your general food choices and the amount you're going to consume and so on.